Hello everyone, welcome to the second part of this video on trigonometry for grade 10. You'll remember that in our last video, which is the first part, we did a lot of work on trigonometry, and in case you have not seen that video, it's important that you go ahead and download it and watch that video first. Because in this video what we will do is to make use of the concepts which have already been taught in the first video. So we're just going to be applying those things in this particular one. So this video is like an addendum to the first part of this video, so ensure that you watch that. And in case you have started to forget any of the concepts taught there, it will be good for you to go over that again. We talked from right angle triangles. We discussed how to determine the various sides of a right angle triangle, to determine the names. We also spoke about trigonometric ratios. We spoke on Pythagoras theorem. We spoke on trigonometric ratios of special angles, and we talked about the application of trigonometry, and we stopped at the angles of elevation and depression. Now that last one is what we are going to be focusing on in this video, and I want you to be able to understand the concept very well so that you can make use of it at any point in time. So the objective of this particular video, unlike the first video, we have one giant objective in this video, and that is to help you to be able to solve practical problems on elevation and depression using trigonometric ratios. You'd remember that I told you that every question on an angle of elevation and depression is aimed at, if you sketch the diagram, you will get a right angled triangle. And when you get right angled triangles, you can either solve it using Pythagoras theorem or trigonometric ratios, which many of you would remember the mnemonic SOHCAHTOA. Okay, so we're going to be using that in examples in this video, and then I'll give you exercises which you will revert back to me so that I could have a clue of how well you have understood the concept. So without wasting time, let's go right into it. We're going to solve examples, and here comes example 1. Now these okay, let me just read. Find the value of w, then x, and round the answer to the nearest tenth. Now this diagram you see on your screen could actually be something you drew from a question on angle of elevation. Okay, if you were given some word problem or based on angle of elevation, you could actually come up with these diagram as the sketch. For example, the vertical line, which is 12 units long, could be the height of a building or a tree or a cliff or something like that. And so if a cliff was standing on the ground, the cliff is 12 units tall, and then some distance away from that cliff you have let's say an angle of elevation, from w units away from the bottom of the cliff. The angle of elevation to the top of the cliff is 42 degrees. So you have that, and then x units further away from the initial point, you could also have the angle of elevation to be 27 degrees, and you just find out that you're able to sketch these diagram. But we have been given the right angle triangles, and then what we need to do is to use our knowledge of right angle triangles to get values for w and x. Now the first thing that I'll do here is to label these shape so that it will be easy. So I have A, B, C, and D. I have A, B, C, and D. And then if you look at this shape very well, you'd realize that there are two right angle triangles in it. Can you name them? Can you see the two right angle triangles there? Okay, there are triangles ABC and ABD. Can you see that? Triangle ABC, that's the smaller right angle triangle, and then it's inscribed inside the bigger triangle, which is triangle ABD. Now sometimes students make mistakes to consider triangle ACD, and even though ACD is also a triangle, but it's important to know that it is not a right angled triangle. Okay, so we're not going to use that at all. We'll use triangles ABC, and then we'll use triangle ABD. Okay, so now what we'll do is to deal with each of these triangles one after the other. So first we'll look at triangle ABC. That's the smaller triangle. Now in that triangle you have a vertical line that is 12 units long, you have an horizontal line that is W units long, and then you have an angle which is 42 degrees. Okay, it's a right angle triangle, and then we have one side, we have one angle, and we are to use that to find the length of the other side. So our theta would be 42 degrees, of course. Our opposite, you remember that opposite is the side that is directly facing the angle in question, or the angle being considered. So it means that the value of our opposite here will be 12, and our adjacent, which is the side that carries both the right angle and the angle being considered, the value of the adjacent, which is line BC, will be W. Okay, so you have adjacent to be equal to W, our opposite equals to 12, and our theta equals to 42 degrees. Now next thing I need to think about is which of the trigonometric functions combines opposite and adjacent. From our SOHCAHTOA, that is tan. The tangent of that angle 42 degree will be equal to the ratio of the opposite and the adjacent. And from here I'm sure that you know exactly what to do. You impute all the values. So theta is 42, you have tan 42 degrees equal to opposite is 12 divided by adjacent, which is W, and then you cross multiply and divide both sides by tan 42 degrees. And if you do all that correctly, your final answer for W will be 13.327. It's actually longer than that, but these are the most significant part of the answer, so I'll leave it at that. 13.327 for the answer for W. But then that's not all. We're also to find the value of X, and to find the value of X we need to consider the bigger triangle. And for the bigger triangle, which is triangle ABD, the opposite, the angle, first and foremost, the angle changes from 42 to 27, because now would act as though the line AC is not there. Okay, we are considering the big triangle ABD. So the angle at D is 27 degrees, so our theta will be 27 degrees. The side that is facing that angle is still the vertical side, which is 12, so our opposite will remain 12. But then our adjacent will become the entire length of line BD, which would be W plus X. Do you understand that? W would represent from B to C, and then X will represent from C to D. So we had both together to get the value of line BD. Okay, so once again we're going to use tangent. Tan of an angle is the opposite divided by the adjacent, so we insert values, and if you do that correctly, your adjacent, which is W plus X, will give you 23.551. And then if that is so, we need the value of X. We already know that W is 13.327, so we subtract that, and X will be 23.551 minus 13.327, and our final answer, X will be equal to 10.224. But then the question tells us to round our answers to the nearest tenth. So we'll do that by saying W is equal to 13.3, which is to the nearest tenth, and X will be 10.2. You can see how easy it is to solve right angle triangles using trigonometric ratios. We'll go to the second example, and this is a word problem, so we are going to have to draw our own triangle by ourselves. It says a cut is 300 meters from the base of a cliff. The angle of depression of the cut from the top of the cliff is 30 degrees. Find the height of the cliff to the nearest meter. So first and foremost, we have a cliff. And a cliff is always a vertical line, a vertical building or something like that. So we'll represent that by this vertical line. That's our cliff. The cliff is standing on the ground, and there's a cut 300 meters away, also on the ground, from the base of the cliff. The base means the foot of the cliff. So the cut is 300 meters away from the foot of the cliff, and there's someone at the top of the cliff, maybe the cut owner, who's looking down at the cut. But initially, before he looks down, this red line will indicate the normal high side of that man. He'll be looking straight, which would have been the horizontal. But then rather than looking in that direction, the man chose to look down at the cut, thus creating an angle of depression of 30 degrees. Do you understand that? Okay, because he looked down, he had to bring down his face 30 degrees before he could see the cut that is on the ground 300 meters away from the cliff upon which he is. All right, now we could decide to make the height of the cliff to be h, because that's what we are going to try to find. It says find the height of the cliff, so we are going to find the value of h. But this right angle triangle does not have an angle inside, so there is no angle being considered yet. And we could decide to find the value of this angle, that angle right there. The angle is inside, and it is a complement of the angle that is outside the right angle triangle. The entire place there, the angle between the vertical and the horizontal is supposed to be 90 degrees. And then we have 30 degrees outside this triangle. It means that the angle inside will be 60 degrees. So we could use that. And then the height of the cliff will be our adjacent side. And then the distance between the foot of the cliff and the cut, which is 300 meters, will be our opposite side. And then we can use our trigonometric ratios. But I won't do that because I will also want to show you a concept. Now, it is also possible for us to get this angle right here at the base. The angle that will be made by the cut if he was to look up at the man or the owner at the top of the cliff. Now, you would realize that this is a giant Z, which implies that the angles there are equal. Alternate angles, you remember that, in form of letter Z. They are equal. The angle 30 degree up here is the same angle that is down here. In the last video, I told you that the angle of depression and the angle of elevation is equal. If I am looking at you at a particular angle of depression, then you would be looking up at me at the same angle of elevation, and that means that here you have 30 degrees. Okay, so this is what I'll use. So my adjacent remains 300 meters this way, and my opposite will be h. So I insert that adjacent is 300 meters because it's the side with two angles. Remember, the right angle at one end and 30 degrees at the other. My opposite side is h, which is the side that is facing the angle being considered. And then my angle theta is 30 degrees. So I insert tan once again, opposite divided by adjacent. And if I do that, it means then 30 degrees is equal to opposite, which is h, divided by adjacent, which is 300. I'll cross multiply from there. My h will be equal to 300 tan 30 degrees. And then you do that multiplication, and your opposite will be 17.205. 173.205, and then to the nearest meter, like the question tells us, is 173 meters. And once again, this is really very easy. I'll do two more examples and then I'll give you exercises to work on. Example number 3. It says a tree is 30 meters tall and it casts a horizontal shadow 32.8 meters long. It says find the angle of elevation of the sun to the nearest degree. So there is a tree and that is 30 meters tall. So you have that, which is the vertical, 30 meters tall. That's the tree. and then somewhere behind the tree the sun is, and the tree casts a shadow right in front of itself, which is longer than the tree itself. So the shadow is right there on the floor or on the ground, and it is 32.8 meters long. Now, what will be the angle of elevation of the sun? The angle we are required to find is that angle theta, which is inside this right angle triangle. Because if someone was on the ground here, the angle at which you have to look up to see the sun is this angle theta right here. Okay, so we have a right angle triangle, two sides given, one angle to be found. So our opposite side will be the side that is facing the angle being considered. We are considering angle theta, so the opposite is 30 meters, and then the adjacent is 32.8 meters, the side that carries both the right angle and the angle being considered. So we have opposite and adjacent. Once again, we'll use tangent. Tan theta equals to opposite over adjacent. We insert values. Tan theta is equal to 30, which is the opposite, divided by the adjacent, which is 32.8. And then if you press your calculator, tan theta would be 0.9146. And then to get the value of theta, you find the second function of tangent, which is arctan, 0.9146. To get that, you just press your second function or your shift in your calculator before pressing the tan button, and then your theta will be equal to 42 degrees. So the angle of elevation of the sun is 42 degrees, and that really is also very easy. Then the last question, but not the least, question 4. It says, at a concert venue, Jenny is sitting 30 meters from the stage by line of sight. That's a very important statement. 30 meters from the stage by line of sight. And it goes on, she is also 7 meters above the level of the stage. That's the vertical distance above the level of the stage, 7 meters. So at what angle of depression is the stage? Now, if I were to solve this question, first thing I'll need to do is to indicate the level of the stage, which is what you have right there. We have an horizontal stage, and that's the level of the stage. Now, it says that Jenny's seat is 7 meters vertically above the stage. So you have a 7 meter line that goes in the vertical direction. Jenny is sitting at the top of that line, 7 meters above the level of the stage. And then by line of sight, that is, if she's looking down, line of sight is the line from your eyes to the object. So Jenny is looking down at the stage, and in looking down, the distance, if you calculated it, would be 30 meters. This is really very important. Okay, the value 30 meters that we are given is not the distance, the horizontal distance between Jenny and the stage. It is the distance from the line of sight. So we're going to follow our eyes down to the stage and we measure, and that's 30 meters. So it says we should find the angle of depression. Angle of depression, obviously, you remember that Jenny would have been looking straight like that if she was looking in the horizontal, but she looked down, and therefore she created an angle of depression. Remember, we said that the angle of depression is always outside the right angle triangle. But once again, the angle of depression is the same as the angle of elevation. If there was an actor on the stage and Jenny looked down a certain angle to see the actor, if the actor were to look up to see Jenny, it would also have used the same angle. So it means that that angle right there, which is the angle of depression, is the same as this angle right here, which is the angle of elevation. So here is also equal to theta. Okay, so we have our right angle triangle. I'm sure you can finish it off from here. You have your opposite to be 7. The hypotenuse is 30 meters because hypotenuse is the longest side. Apart from that is the side that's facing the right angle. And then you have 30 meters, opposite is 7 meters, and we are trying to find the value of theta. Okay, if we do that, opposite and hypotenuse, that will be sine. So the sine of that angle will be equal to opposite divided by the hypotenuse. We insert values. Sine theta will be equal to 7 divided by 30. which if you press your calculator will be 0.2333, and then you find the arc sign of that value, arc sign 0.2333, and your final answer will be 13.49 degrees. 13.49 degrees. So now I'll leave this answer this way anyway, because we're not told to make it to be in to the nearest degree or anything like that. So you could leave your answer this way, or if you want to approximate to a particular number of decimal places or whatever the case may be, ensure that you indicate that. But there is no problem if you left it without doing that at all. Okay, so those are the 4 examples that I have for you in this video. I believe that with these examples you have a clearer understanding of solving questions on angles of elevation and depression, and to be able to gauge how well you have understood the concept, I'll give you these exercises. There are 4 of them on your screen right now. So you might just want to pause the video so that you could maybe copy them out or something, so that you can solve them by yourself. Okay, and once you're done with that, I'd expect your answers to be submitted to the email on your screen. Okay, submit to the email on your screen. SGC should submit to that email, and SHS should submit to the other one, and on or before the time that you have on your screen. Okay, and then once we get that, I'll be able to go through and revert back to you on this. I expect that by now you have a very good understanding of trigonometry up till this point. Okay, the next point we'll be going with trigonometry will be into bearings, but definitely that is not going to be in this video. All right, so have a wonderful time. I'll see you some other time. Okay, bye bye.